before we're going to start talking about inequalities for one triangle, I want to develop the idea between a opposite side and interior angles, okay, of a triangle. So I'm going to give you a triangle here. I'm going to draw it. Do your best to draw this one just like this, like that, like this, and then like this. Okay? Alright, so there is my triangle that I have drawn. Best of your ability. Let's talk about the sides. Which side do you think is the longest?
The one that goes diagonal.
The one that goes diagonal. Come, I'm going to highlight that one right here. Alright? Well, he says the hypotenuse, but that would be a right triangle, and this is not necessarily a right triangle, but you're on the right track. Yeah. Alright, that side is the longest, okay? So I'm gonna highlight that one and call that longest side. It would be the hypotenuse if this triangle was a right triangle, but this is not necessarily a right triangle. All I know is that's the longest side. Okay, now, which other side of the other two is the shortest side? On the left. So the one I'm going to highlight in blue here. You guys agree that this one right here, is that the shortest side?
Yeah.
I would agree with that too. That's the shortest side. Okay, so I have the longest side, and then I have the shortest side. Alright, so we've identified the shortest side, which we think is this one, and the longest side, which we think is that one. Okay, now, let's look on the interior angles, okay? Which angle do you think is the biggest?
The bottom left.
This one here?
Yeah.
Okay, I'm going to highlight that one in yellow. We think that one is the biggest angle, right? Biggest angle, okay? Okay, and which one do you think is the smallest angle? This one over here? This one over there, and I'm going to highlight that one in blue. Okay? And we think that one is our smallest angle. Alright? What do you notice? You notice anything?
Yes.
In the relationship between the side and the angle. Who can put a sentence together? Yeah, what do you think, Nick?
The angle is like approximately across from its corresponding side. Like
Okay, you're almost there. Like 80% there. You're totally on the right track. Yeah. Want to try again?
this side is adjacent to the angle.
You're on the right track. Okay, Alessandro, you can help him out?
For example, on this one, the longest side, or the biggest angle is the one that's not touching the longest side.
Okay, you're also on the right track. You're even closer. What do you think, Juliana? Yeah. Would you guys agree with this statement? The longest side of the triangle is opposite the biggest angle. Is that true?
Yes.
Would you agree with this statement? The smallest side of the triangle is opposite the smallest angle. You guys agree with that one?
Yes.
And then, of course, the other angle is just the other angle, right? And the other side. So, here's what we need to come up with, okay? Largest side. Yeah, it's just a fact. Largest side is opposite largest angle. And smallest side is opposite what? Smallest angle. There we go. That's what we need to understand, the relationship between our sides and our angles. Okay, this is sort of it feels like it's a given, but it's actually a theorem, and so we're gonna state it and talk about it. So I have a line L. Fair enough. There's the line L. I have a point, and we'll call that point P for now. And that point P is not on the line, so that is not a collinear point, right? That point is not on the line. So the question is, what's the shortest distance from that line to that point? What do you think? It's definitely going to be straight, okay? But here's the problem with the word straight. That is straight.
Perpendicular.
Ah, there you go. You found something else. Okay, you've actually figured it out. So that is straight, but that's not what we want, right? This is what we want. Turns out that is the shortest distance from that point to the line. So the theorem says this. And it's a theorem, so we can use it in proofs. Unfortunately, there's no real shorthand for it. It says the perpendicular segment from a point to a line is the shortest possible distance from that point to the line. All right, the major part of section 6.4 is the triangle inequality theorem. So it's a theorem, so we can use it. So we have to know how and when to use this. It's the triangle inequality theorem. And here's the structure as to how it happens, or what it says. I have 3 line segments here, okay? Not necessarily drawn to scale, but as close as I could get it for right now. One segment is 6 units long. The other segment is 13 units long. The other segment is 30 units long. So assuming that the segments are the right length, but maybe the numbers aren't. Can you make a triangle out of those segments there? You'd say yes, right?
Yeah. No.
You can't.
Because they don't add up to 20.
These are just segments. So can I change these around, right?
No, you
Because when you do the long line side,
Okay, so here you go. I'm going to take that 13, and that's the purple one. So I'm going to like draw it approximately the same length. Is that approximately the same length?
Yeah.
Okay, and then if I draw the other one, that's approximately 6, okay, which I think was this color, are they ever going to touch?
what if you do like this?
But yeah, with your angle of 30.
They are eventually going to touch.
No. I have these segments. These are specific lengths.
Have to be.
They're line segments. They're only this long. And this one's only this long. And this one's only this one. Okay? So, is it going to work? It's not going to work. Okay? So, I can't make a triangle out of just any old 3 segments, right? Ashley, what do you think? Yeah, exactly. Okay, you're on the right track there. So if 30 is too big, what number would work then? What number do you think would work? And how do we figure out? That's the 17. Okay, why 17?
Because when you add 6 and 13 equals 19.
Okay, so let's do this. Let's imagine, like, for a second, I wonder if I could do this, right? Where's my drawing tool? Yeah, here we go. Check this out. So what if I took this segment right here, okay, and I put it over here, okay? How long would that then segment need to be? That would be a grand total of 19, right? But if I had a segment that was 19 units long, would that make a triangle? No, it'd make a straight line, right? So that segment needs to be less than 19 units, right? So if I add 6 and 13, I get 6 plus 13, I get 19. But if my third segment was 19 units long, it would make a straight line. So it needs to be smaller than 19, right? So it needs to be less than 19 units. Now let's take the other extreme case, okay? What if I took this segment here, this segment that I had was 13, okay? And I line them up right on top of each other here. How much is left over?
7.
How much is this segment, this new segment? It'd be 7, right? And that would be too small. So it needs to be between 7, so some segment here, my third side, and 19. So 7 and 19. This is what the triangle theorem is saying. It's saying that the sum of any 2 sides needs to be smaller than the third. The sum of any 2 sides of a triangle needs to be smaller than the third. Okay? So how do we use this? Because obviously 30 was too big in this case, right? So how do we use this? Let's talk about some examples. Okay? Let's say you're given 2 sides. You're given 2 sides. One side is 11 inches long, and the other side is 17 inches long. You're trying to come up with the third side. Okay? I want to know what 2 numbers does that third side need to be between in order for it to actually be able to make a triangle. So this is how we're going to use the triangle inequality theorem. If I have 11 inches and I have 17 inches, what is the length of that third side. That will actually make a triangle. I go up now? Okay, thanks. Good. So what do we do? We figure out. What do you think, Alessandro?
Anywhere from 6 to 28 inches.
Very good. So I'm going to take both sides. I'm going to add them together. And now we get how much? I get 28 inches, right? And then if I take 17 and I subtract 11, I'd get 6 inches. So my third side needs to be somewhere between 6 inches, third side, and 28 inches. Okay? This is what the triangle inequality theorem is saying.
Would that be the answer then?
Yeah, it can be anywhere between 6 and 28. Notice that it cannot be 6, and notice that it cannot be 28. How come? Because they don't have an equal sign there. If it was 6, yeah, if it was exactly 6, I get a straight line. If it was exactly 28, I get a straight line. So there needs to be somewhere between. So could the third side be 11? Sure, it could. Could the third side be 14? Could the third side be 5? No, it'd be too short. Wouldn't work. Could the third side be 30? No, it'd be too long. It wouldn't work out for us, okay? Give me an example of one that would work. What would work in our inequality? Okay, 7. Okay, 7 inches. That would work. Now, so I have 3 sides. I have 11, I have 7, and I have 17. Okay? That means the sum of any two of them needs to be greater than the third one. So let's add these two together. How much is 11 and 7? 18. Is that bigger than this? It sure is. Let's take 7 and 17. Well, that's already bigger than 11, right? Let's take 11 and 17. That's already bigger than 7. So the sum of any two of them is bigger than the third. That's what this inequality theorem is saying.
It has to be bigger.
Has to be bigger than the third.